Okay, Bismillahirrahmanirrahim. Welcome to the class of Irrigation Engineering for 2-hour lecture. This is Dr. Noor and I am with section B and C. So today we are supposed to study different methods of irrigation which are practiced in field. So considering you people as irrigation engineering, you should be familiar with these methods so that the practice which is going on should be known to you. So before going to this topic, if you people have any questions regarding last lecture, so you are welcome to ask. किसी के पास कोई सवाल है पिछले लेक्चर के मुतालिक? लास्ट टाइम
सर जो शुगर केन है उसका जो डिस्चार्ज है उसको हम रबी में ऐड करेंगे या उसके साथ खरीफ के साथ?
वाटर रिक्वायरमेंट उसका डिस्चार्ज नहीं होता, वो वाटर रिक्वायरमेंट ऑफ द शुगर केन का कोई डिस्चार्ज नहीं है, ठीक है। पहले तो
क्वेश्चन में डिस्चार्ज पूछा हुआ है ना सर कि खरीफ और रबी के लिए डिस्चार्ज फाइंड करें।
ओके, फाइंड द वाटर रिक्वायरमेंट फॉर रबी एंड खरीफ, यूँ कर लो, ठीक हो गया। जो चीज़ आप कह रहे हो मैं समझ गया हूँ, लेकिन कहना कि शुगर केन का जो डिस्चार्ज है वो दैट डज नॉट सेम गुड। The water requirement for sugar cane that can be expressed in flow rate discharge, that can be expressed in depth, है एक्चुअली वो वाटर रिक्वायरमेंट है। पहली बात तो ये, ठीक हो गया। 1 2
और
0
सर जो शुगर केन की ड्यूटी ज्यादा लिखी हुई है उस प्रॉब्लम में और वीट की ड्यूटी 1800 लिखी हुई है जबकि शुगर केन की 2200।
ओके, तो पहला सवाल आंसर हो गया, जो दूसरे पे आ गया। 1 2 0 पहला क्वेश्चन आंसर हो गया था, जो दूसरे पे आ गया।
आपने बता दिया सर, वो डेप्थ वाटर क्रॉप की वो लेते हैं हमसे।
मैंने कुछ नहीं बताया, मैंने तो अभी तुम्हारा क्वेश्चन सही किया। है 1 2 0 नाम क्या है तुम्हारा?
हसीब सर।
नसीब, कोई सवाल का जवाब मैंने नहीं दिया मेरे ख्याल में। ओके, so your first question was I rephrase it, whether we should add the sugarcane water requirement in Rabi or Kharif। ये आपका पहला सवाल था जिसको आप कह रहे थे शुगर केन का डिस्चार्ज जी मैं किस में डालूं, रबी में या खरीफ में, यही था ना?
यस सर।
So water requirement for Rabi and Kharif, if you have to calculate where does the sugarcane water requirement will go. So it will be added in both of them. So not the whole water requirement in depth unit. In depth unit, water requirement for sugarcane is for the whole 330 days. So we have to divide that total water requirement of 330 days, or we should convert it into the discharge. Then that discharge can be added in Rabi crop wheat also, and that can be also added in Kharif crop, because sugarcane need water in both the season. तो ये तो बड़ा लॉजिकल आंसर था इसका। सोचो एक ज़मीन है, उसमें एक फसल है वो 330 दिन के लिए मौजूद है या 360 दिन के लिए मौजूद है, जैसे इसका बेस पीरियड बताया हुआ 330 डेज। एक फसल है वो 6 मंथ के लिए आई है, जैसे वीट है या राइस है। तो जिस वक्त वीट मौजूद है उस वक्त शुगर केन भी मौजूद है, तो वाटर रिक्वायरमेंट विल बी सम ऑफ दीज टू। जब राइस मौजूद है तो उस वक्त शुगर केन मौजूद है, तो ड्यूरिंग खरीफ इट विल बी राइस प्लस शुगर केन। दैट वाज ऑब्वियस आंसर। अब बताओ, हैव आई आंसर्ड योर क्वेश्चन, पहला वाला क्वेश्चन?
यस सर।
ओके, तो ये बात तुम्हें क्यों नहीं ख्याल आई? There was only difference. One was on the field for the whole year or 330 days. One was on the field for 4 months or 5 months. So for today water requirement, you see what crops are there in the field. For today or for April water requirement, you have to see which crops are there in the field. So their water requirement will be added together. and canal is supposed to provide that water. और केनाल जब हम डिज़ाइन करते हैं तो हम सारे साल की on 10 daily basis or 7 daily basis we compute the water requirement based upon the crop present in the field for those 7 days or for those 10 days. So we add water requirement for all the crops and then we see which one is the highest one and that one we take as a design discharge of the canal if we are planning a new canal. तो ये तुम्हारे पहले क्वेश्चन का आंसर था और I was expecting you people should be knowing it. And I think I informed this also in the last lecture, either your section or the section A and D. किसी को बताया था मैंने एक बार. Second question was तुम्हारा second question क्या था? Quantity was different. You said quantity is different, duty is different. Different rather for rice it is less. क्या क्या बताया था आपने?
शुगर केन के लिए ड्यूटी 2200 लिखी हुई थी सर और वीट के लिए 1800.
सही हो गया. कहाँ है ये सवाल? This one.
Yes sir.
Duty is number of hectares which a cubic can irrigate. Definition याद है ड्यूटी की? Number of hectares what one cubic can irrigate. If that cubic is provided for the whole base period. ठीक है? तो बिल्कुल ये लॉजिकल है, ठीक है ये दोनों, ये 800 और ये 2200. सोचो जरा.
वीट की ज्यादा नहीं आनी चाहिए सर, क्योंकि वो तो बिल्कुल कम डेल्टा यूज करती है वीट.
अब मैं अभी राइस और शुगर केन का कंपेयर कर लूं फिर वीट की तरफ आते हैं. आपने पहले राइस और शुगर केन का ही बोला था ना?
नहीं, वीट और शुगर केन का सर.
ओके, वीट और शुगर केन को देख लेते हैं. वीट नीड्स लेस डेल्टा, दैट्स ट्रू. Delta for wheat is less, so he is saying that it is 1800 hectares per cubic will be irrigated. And if it is sugar cane, it is 22 hectares will be irrigated. ठीक है. Hopefully it is fine. Reason is wheat need this wheat need this delta wise it's small. Delta for wheat is small, delta for rice is large. Delta is the amount of water which we have to provide during the base period. So because its base period is small, so overall delta is small. ठीक हो गया. और चूंकि उसका बेस पीरियड लार्जर है, हो सकता है उसका पर डे डिमांड वीट से कम हो सकता है, और लेकिन ओवरऑल उसका डेल्टा हायर होता है शुगर केन का. डेल्टा वाइज समझ आ गई बात की?
यस सर.
तो डेल्टा वाइज हमने पहले जो आपको इंफॉर्मेशन दी है, फॉर वीट लेस वाटर इज रिक्वायर्ड. रीजन इज स्मॉलर बेस पीरियड. रीजन इज इट्स स्मॉलर हाइट आल्सो. Sugar cane is more water intensive. Reason is larger time duration. Overall delta will be high. Delta is not the water required per day. It is the overall water required for the whole base period. So delta wise that's fine. Now let us see duty. So duty represents how much area I can irrigate using using the unit quantity of water supplied for the whole base period. That is a duty. So if they are mentioning it, it means that per day water requirement seems to be small for sugar cane, or maybe there are time duration when sugar cane needs smaller quantity of the water, and there are time duration when sugar cane needs a smaller quantity during the harvesting time also. So that's why overall with the same quantity of water, if we supply for the 330 days, same discharge if we supply for the 330 days, if it is sugar cane, they are saying 2200 will be irrigated. So I think they are fine. मेरा नहीं ख्याल इसमें कोई गलती होगी. उसके ओवरऑल पर डे रिक्वायरमेंट हो सकता है कम हो, पर डे रिक्वायरमेंट के हिसाब से कम हो, तो हम ज़्यादा एरिया इरिगेट कर सकें. We can confirm it from some other source also. ये भी यानी किसी बुक से कॉपी किया हुआ है ये क्वेश्चन, आई हैव नॉट मेड इट. So we can confirm it from some other source also, literature या अपने irrigation की बुक से देख सकते हैं कि शुगर केन की ड्यूटी क्या बनती है. If you use that data, तो ड्यूटी हम निकाल सकते हैं. If you use the data I have provided to you for PCRWR, over here they are telling you the delta. For example, there is wheat, delta is 421, and there is sugar cane, delta is 1543. Can we convert it using the formula of delta into duty? Use 330 days as the base period for sugar cane and use how many days? उसके लिए क्या डे थे? वीट के लिए 120 डेज अगर हम यूज करें तो लेट अस सी हम क्या कैलकुलेट करते हैं. इफ डेल्टा इज नोन, लेट अस कैलकुलेट द ड्यूटी. And we are using another source. We are using the data of another source. ये मैं स्लाइड को यूज करते हुए, if anybody will open the Microsoft Excel and calculate duty or delta. क्या फार्मूला था डेल्टा का? Who will tell me? Delta was
864
delta
864 B over D.
equal to 864 B over D. Now B and now delta is with us. We have to calculate duty. तो ड्यूटी का क्या फार्मूला बन जाएगा? ड्यूटी इज इक्वल टू 864 B over डेल्टा. ये बन जाएगा फार्मूला. ड्यूटी विल बी इक्वल टू 864 B over D डेल्टा. सो B अगर ये है 330 डेज फॉर शुगर केन, डेल्टा वाज 1. डेल्टा कितना था? 154.3 सेंटीमीटर्स में. 154.3 सेंटीमीटर. 154.3 centimeters. So duty will be equal to plus 864 B divided by delta.
Delta 154 sir 1154 है.
That is millimeter ना. ये जो फार्मूला आपने मुझे बताया है ये फार्मूला सेंटीमीटर के लिए है.
ओके सर.
ये जो डेल्टा का फार्मूला आपने मुझे बताया, आपने मुझे सेंटीमीटर वाला बताया. दूसरा फार्मूला था 8.64 B over D. That was delta will come in meters. If B is in day and duty is in hectares. समझ आ गई?
यस सर.
तो ये तकरीबन 1800 ड्यूटी के यूनिट्स वगैरह पता है?
यस सर. हेक्टर पर मीटर क्यूब.
E will
per
be
cubic.
days, delta will be in centimeter, duty will be in hectares. हम दूसरे की तरफ आते हैं. ये था शुगर केन, क्या था वीट. वीट के हम लेते हैं 120 डेज. यही लिए हुए थे उन्होंने.
यस सर.
ओके, इसके डेल्टा हम ले लेते हैं 42 सेंटीमीटर. 42 सेंटीमीटर इसका फार्मूला. सो इट्स ड्यूटी शुड हैव बीन मोर. अगर हम ये डेल्टा यूज करें, अगर मैं 37 यूज करूं तो ये और भी बढ़ जाता है. यू आर राइट, उनका डाटा में मसला है, बट दैट इज फ्रॉम अ बुक. आपकी ऑब्जर्वेशन ठीक है. ठीक हो गया. इसकी
Yes, sir.
ज़्यादा आनी चाहिए थी. तो अगर 120 को मैं क्या कर दूं, 90 डेज की अगर करूं तो फिर वो कम हो जाती है. So that is how we relate delta and duty. Your observation was right in the question. More plausible value should have been written, but that is taken from book of irrigation engineering. किस बुक से लिया है मुझे इस वक्त नहीं पता. तो आगे चलें इसमें। वीट 1800 दिखाई हुई है और शुगर कैन की 2200 दिखाई हुई है। इट शुड हैव बीन अपोजिट। चलो राइस को कैलकुलेट करते हैं 120 डेज और डेल्टा राइस का हम उनका डेल्टा भी सही नहीं था। राइस का डेल्टा अगर हम यूज करें जो हमने पहले पढ़ा हुआ है, सेम फॉर राइस इफ वी कैलकुलेट इट 120 डेज डेल्टा हमने इसका पढ़ा हुआ है तकरीबन 150 या 100 सेंटीमीटर। इट विल इरिगेट अबाउट 1000 हेक्टर्स। अगर राइस लगा हुआ है तो 1000 हेक्टर जो है वो इरिगेट हो सकेंगे फॉर यूजिंग अ क्यूबिक ऑफ वाटर। So that is how we relate them. Okay, your observation is right. This should have been opposite written over there. आगे चलें?
Yes, sir.
Okay, 60 students are with me. Any other questions? Thanks, Haseeb. Haseeb नाम बताया था 120.
Yes, sir.
Okay, thanks Haseeb for your pointing out. 147 कुछ कहना चाहता है? So, any other questions?
सर कितनी डिप्लीशन को हम अलाउ करते हैं? विल्टिंग पॉइंट पर ही पानी हम देते हैं, वाटरिंग करते हैं, या थोड़ा सा अबव लेवल पे?
ये बात मैं बता चुका हूँ। We don't let them go to the wilting point. और it is not fixed है कितना ऊपर. It depends upon your surety of availability of water. कि आपको जिस दिन आपने पानी लगाना चाह रहे हो, the day on which you want to irrigate, how much sure you are that you will be having the water. It will depend on
ओके
that.
सर.
If you are sure, for example, dew well is with you, and you are sure whenever you would like to irrigate, you can irrigate. Then you can go close to wilting point, because just maybe you can put 5-10% as the margin. But those people who are not sure that water will be available on the day of irrigation, then they can irrigate after 50% of the available moisture content is depleted. इसका मतलब है अभी भी 50% margin was available, so that he can keep it. So 70-80% is a good value in between. When 80% of the moisture content is depleted, irrigate it, or 70% of the moisture content is depleted, irrigate it. और इस तरह का कोई सवाल? Okay, so we move towards today's topic, that is method of irrigation. Maybe some of you are already familiar with these methods because of living in village environment, and maybe for some of you, these terminologies are new for you. So we want to introduce you what are different methods which are practiced, and I have put some links in the slides. Maybe these links are not there in the slides which I have conveyed to you. So please, for example, method of irrigation have been described by Food and Agriculture Organization. They have put a chapter, and this is available online, and a PDF is also available with me. So these methods are described in this handbook, or we can say literature related to irrigation provided by Food and Agriculture Organization. So there are different method of irrigation. While we are talking this method of irrigation, it means method of irrigation with respect to application of water in the field. Method of irrigation with respect to how we convey water or how we make the water available in a certain area, that is different. For example, we say that we are dealing with the gravity irrigation method. One is this. So that means we are providing water through the gravity force, movement of the water through the gravity force, like it is moving in our open channel or canals. So that thing is separate method of irrigation, how to supply water at a certain place. So in that respect, irrigation methods can be described gravity method and lift method. So those are two methods being utilized. The irrigation canal is actually a gravity method of application of water. So once water is available in the field, so then how to apply water to the field. So those differences, those variations are described in this topic. It can be applied to the cropland using variety of the ways, which can be categorized into these four kinds. One, we say that the surface irrigation method, we apply water from the surface in the open environment, in the open channel environment. Second is the subsurface irrigation method, and one is we apply water in the form of the droplets through sprinkler irrigation system, and one we supply water in the form of small droplets or small drips continuously supplied to the root zone, continuously supplied to the plant individually. So these are the four kinds of method. So these surface methods are the traditional method of application of water. These sprinkler and trickle irrigation or drip irrigation method are considered as a modern or high efficiency method, high efficiency irrigation method. Same thing have been described in this flow chart format, that irrigation method can be divided into these four kinds. So each of them have can be categorized into further subcategories. For example, surface water application can be said to be border or strip, check basin or furrow method, and sprinkler method can be divided into rotating head methods, perforated pipes method, or there can be more pivotal sprinkler irrigations methods. So there can be further description, and each of these methods can be further subcategorized depending upon whether they are being applied by dividing the field based upon the elevation difference, that is dividing the field into different contours. So one field at one level, the neighboring field at a higher level. So we say this is a contour method of irrigation, or we are applying this surface irrigation on a straight farmland. Throughout the farmland is plain or straight. So depending upon them. Similarly, check basin can be of different shapes, rectangular, contour based, or ring. Similarly, furrow method can be deep furrow or shallow furrow. So that can be straight or based upon contours. If the field or kiari or the plot on which we are applying water, its shape is regular, so then it can be rectangular or square or circular. But if the shape follows the shape of the contour, so then we say this is the we say we have made the terraces, or we are applying the water based upon the contours of the field. So that is the differentiation between these two contour methods and other shapes. So in contour method, we make the field or kiari in the same shape as the contour is varying. We don't want to carry out more earthwork. We don't want to apply more labor. So that is how these contour methods and other methods are differentiated from each other. Yesterday I have seen this video. It is different kinds of irrigation methods are described over here, including some of the methods which are not mentioned over here. For example, they are including the application of irrigation with the help of that is a kind of lift irrigation. Rahat, we in local language we call it rahat, or in Persian wheel. In English, they call it Persian wheel. That is also described in this video. So some of these methods are described over there. For example, in this video, sprinkler method is described, and some of the other methods which are not mentioned in these slides are also described. This is short video. I think 10-12 minutes or video is there. So please see it whenever you are free. So if we go to these methods one by one, first method which is most commonly used is the surface irrigation method, and it is the oldest and the most common method as described over here. It is characterized with a low efficiency because we apply water through open channel, and we apply water while water is standing in the field for longer duration, so more evaporation is there, and depending upon how much undulating is the field, how much unbalanced is the field, it has higher losses with respect to deep percolation and with respect to evaporation. So low efficiency is its main characteristics, but on the other side, less labor is required in applying the surface irrigation method, and a low cost method. So we need less cost for preparation of the field as compared to methods like sprinkler, and as compared to the method like drip irrigation. Surface irrigation method we can apply by less initial cost. So their application efficiency uh, uh, ranges from 40 to 80%, uh, depending upon which method out of the surface irrigation method we are applying. Within surface irrigation method, there are 3, 4, 5 different methods. For example, the best one in surface irrigation method is furrow irrigation method. It can reach up to 70-80% of application efficiency. This application efficiency is a special term used in irrigation. It has a proper definition. Let us see that definition first, that is given in the last slide, I think.
सर
Application
लेवल ऑफ
efficiency.
परफॉर्मेंस का बता
A level of performance is measured through these efficiencies. That is what I am telling you. We can measure the level of performance with the help of these efficiencies. One is application efficiency. Application efficiency is defined as water used by the crop divided by water supplied in the field. If I have supplied 10 millimeter of the water to the field, whether actually this 10 millimeter is utilized by the crop, or it has been percolated down, or it has been drained to some other field, so that affect the efficiency that we call as application efficiency. In comparison to this, sometimes we measure the efficiency of application of the water. We call that thing as water use efficiency. So that is how much yield of the crop has been produced. So how much output of the crop we are receiving by application of a unit quantity of water at the field. A cubic meter of the water, if it is provided, how much kg of the crop is being produced. So that is water use efficiency. So depending upon these efficiencies, uh, this application efficiency for surface irrigation method varies from 40 to 80%. That is, about 40 to 80% of the water will be utilized by the crop as compared to what we have provided to the field. So rest will be lost in this method. So that will be the efficiency at the field. Conveyance losses are in addition to that. Okay, so coming to this, the first method within the surface irrigation methods is uncontrolled flooding. If we apply water to land without proper preparation of the land and without any control on the flow of the water on the field, and in the surface irrigation method, we get the control of flow of water by the small ridges made in the field. छोटे छोटे बंद अगर हम बना दें फील्ड में तो वो हम कंट्रोल कर रहे होते हैं. But if we apply the water without making any control in the field, so then we say this is an uncontrolled flooding, and it happens when we have unlimited amount of water and we leave water to a certain area without first proper preparation of the land, making small fields or small quarries over there. So when water is applied to the cropland without any preparation of the land and without any levees, levees are the small embankments, small ridges. छोटे छोटे अगर हम बंद बना दें 1 feet 2 feet high within the field, people make it, they have to make it. so that the water should remain controlled within that area when they are applying water to that area. So levees or band or ridges are the same thing. So if without making any levees, without making any kiari, without making any field prepared, if we apply water, we say this is uncontrolled flooding. So this method, uh, in this method, we bring the water to the field with the help of the channels or ditches, and then admit that water on the field on one side without any control. It is generally results in excess irrigation at the head of the field, because that will be soaked for longer time, and it will be having insufficient irrigation at the far end of that field, outlet close to the outlet of the field. Application efficiency is reduced because either there will be deep percolation or there will be drainage of the water from that area. No control is applied, so water can drain from to the other area. So that's why this is one of the method not widely practiced, but we have to tell you that this is also one of the surface irrigation method. In comparison to that, it's for uncontrolled flooding, application efficiency is obviously small. This method is suitable when water is available in large quantity. When you have no problem of water availability, then we can use this water, this way of irrigation. But of course, in Pakistan we have the shortage of water, so it is not widely practiced. During flood season, if we leave the water open and it irrigates certain land, so that can be said to be as uncontrolled flooding. This is, I cannot say this is uncontrolled flooding. This picture is not uncontrolled flooding because it is well prepared land over here, and there are ridges available over here, if you can see. So we can say this is the surface flooding method. We can call it as a border or strip irrigation method. So second method of irrigation is border method or strip method. So in border irrigation method, the whole field is divided into small strips. So let us see its figure first. For example, we are showing you how the field will be prepared if we want to use the border or strip irrigation method. Same thing, but two names are there. So if the field is prepared in the shape of a strip or in the shape of a border, so that is irrigation method is called as strip irrigation method or border irrigation method. In this method, or this method is suitable when we have slope in both the direction. In the direction of the flow of water, we have slope of the land, and in transverse direction, if the land is having an inclination or slope. So to avoid the haphazard application of the water, the land is divided into the smaller width strips of varying from 3 to 20 meter and length varying from 100 to 400 meter. We divide the land into small strips. Within the strip, within this width wise, we make this field leveled. So we have the same elevation within one strip. Maybe next strip is higher or lower, but having the same elevation. Next strip is higher or lower, but the same. And there will be a gentle slope in the direction of the flow of water. So this is suitable when we have a slope of up 0.2 to 0.4% in the land. Then this method is suitable, but people have used this method for slope as high as up to 8% in the land. People have used it. So this method is widely practiced when you have cross slope. So to avoid the problem of that cross slope, the land is divided into smaller strips. The slope in the direction of the flow, that is utilized to move the water. There is some guideline available that if slope is so much, then size of the field should be so much, and there is guideline available that in which kind of soil this method should be utilized. In all these methods, water is provided to the field, to the land with the help of the field ditches. ये जो field channel है वो पानी supply करेगी, and from the field ditch either we will be cutting the ridge of the ditch or we will be providing water to each strip with the help of siphons. Siphon are the inverted pipes which once they become full, they supply water because of the difference of head in the ditch and in the field. So for practicing this siphon method of water provision to the strip, this strip should be at the lower elevation and the water level in the ditch should be at higher elevation. तो इसकी भी एक अगर आपको मैं कहूँ कि वीडियो देखो, that make you more make it easy for you to understand how this siphon works. मोहम्मद अरसलान अहमद, मोहम्मद अरसलान अहमद, बेटे आपका माइक ऑन है. इसका कोई फ्रेंड है तो इसको बता दे, ये ना हमारी बात सुन रहे हैं और ना अपना माइक ऑफ कर रहे हैं. ओके. So a couple of things I have told you while I am telling you the strip method or border method. One is the shape of the strip. I have told you width wise it will be smaller, length wise it will be larger. Along the width it will be having the level ground or it will be having no slope, while along the length it will be having a gentle slope. From the head, from one side where the elevation is higher, the water is supplied at the head of the strip and then it moves towards the tail of the strip. And sometimes we have a drainage ditch also over here. Water is supplied to the whole land with the help of the supply ditch over here, and then either cutting the side of the ditch or by siphon we can supply water to the strip. Video for this I think is placed somewhere. कहाँ रखी है मैंने? साइफन इरिगेशन कैसे काम करती है. So that is how this siphon is provided. For example, this figure is actually furrow method of irrigation, but to make you understand how the siphon works, there is this supply channel or supply ditch over here. So it will be at higher elevation. Water level in this ditch will be higher as compared to the level of the ground in the strip or in the furrow where we want to supply water. So one way of supplying water from the ditch to the furrow or strip is cutting this bank. Another way is by providing these siphon-like pipes, by providing these pipes which connect the water in the ditch to the land where we want to supply water. For use of siphon, see this video. तो ये यहाँ पे मैंने रखी हुई है, इसको अगर मैं copy paste करूँ, you can see this, or you can see it at your own. कैसे से कॉपी करूं? Let's see. So she is using this. She is using this pipe to supply water from this supply channel into the field over here, and you can see there's a huge difference of the level. So they are using this siphon method for supplying water from the channel to the strips or furrow on the other side. So please see it. There is a special way how to make this siphon work. This siphon will start working when it is full with the water. So to make it full with the water, she used the suction pressure by putting hand on one side of the pipe and then pushing this pipe into the channel. While she is pushing it into the channel, hand is removed. But while she is pulling this pipe from the channel, then she put the hand on the front end of the pipe. So that is how they carry out this siphon method of irrigation. I don't know if you are getting its voice or not. आपको इसकी वीडियो की आवाज नहीं आ रही होगी hopefully. So you can see it at your own place by searching in the YouTube irrigation with the siphon. If you search it, you will be getting this. So ये इसने बताया when you are pushing this pipe into the channel, remove your hand from the end of the pipe, and while you are pulling it back, put your hand at the front end. So the water which go into the pipe, that will remain within the pipe, and then when she put it again, more water comes into it, and finally it becomes filled with the water, and then siphon action starts, and it continuously flow, and it will continuously flow till water level in the parent ditch, water level in the supply ditch is higher as compared to the water level in the receiving field. So I let it move further. That is how she is practicing. So that is what I wanted to show you कि siphon irrigation लोग कैसे practice करते हैं. पाकिस्तान में जो मैंने देखा है, people are just cutting this edge and they supply water and then they close this ditch with the help of the material available over there. तो पाकिस्तान में siphon मैंने इतना use होते देखा नहीं है. Okay, going back to our
हमारे पंजाब में
बोलो, जोर से बोलो.
सर जो कैनाल्स या छोटे कैनाल्स बह रही होती हैं फील्ड्स में, तो सारी ये साइफन्स का यूज़ इलीगल नहीं समझा जाता कि आप अपनी जो क्वांटिटी है आपको अलाउ है वाराबंदी सिस्टम में.
सही कह रहे हो, but you are mixing with two things. Getting water out of the canal, distributary or minor, with the help of the siphon, which is not approved by the irrigation department, that is illegal. But getting water from the water course when that water is available to your field at that time, so using siphon or cutting the edge, both are the same thing then.
सर साइफन यूज़ क्यों करना है, वो कटिंग में क्या हर्ज है?
I think by just seeing it you can see its benefit. Cutting करना और फिर उसको fill करना is more laborious. When you want to stop this siphon method, when you want to stop this siphon working, just pull pipe को ऊपर कर दो, ये रुक जाएगा पानी की सप्लाई. ये लेस लेबोरियस है, ये तो इसके सीधा सीधा बेनिफिट यही है.
जी बेहतर सर.
ठीक है. We usually in Punjab we don't have much head difference. That's why we cannot practice this method. It needs some head difference between the parent channel and the field. इसलिए इतनी प्रैक्टिस नहीं की जाती, वरना तो इसका obvious there is a obvious benefit, less laborious. For example, you can see even another video in which 100 of these siphons were tied together. That was like a pipe. They supplied a pipe from the main channel to the field, and the pipe was vertical upward in the channel. जो उसका direction थी वो standing direction में था, and that pipe could be rotated. So उन सारे 10, 20, 100 pipes को they have linked it with a rope. When they wanted that it should work, they pull it and its level go down and pipes start working. When they want that it should not work, they pull the rope on the other side. Pipe का जो inlet है वो ऊपर चला जाता है, तो वो stop working कर लेते हैं. So people are using different ways to reduce their labor, to reduce their work. So that is how people are using it. So anybody will tell me whose mic is on. अब ये कौन है? सईद रहमान या सैद रहमान? Said Rahman, you are getting my voice. ऐसे बच्चों को मैं क्यों ना निकाल दूं या माफ कर दूं. Who can mute? Anybody have authority के mute कर दिया करे? CR, can you mute the students? ताकि मुझे यहाँ रुकना ना पड़े. ये ना बैठा हुआ है, ना सुन रहा है, ना कुछ अटेंडेंस के लिए आया हुआ है. सैयद रहमान, I cannot listen to you, but your mic is on. CR,
यस सर.
ये क्या आप माइक म्यूट कर सकते हो स्टूडेंट के?
नो सर, ये अथॉरिटी नहीं है स्टूडेंट्स के पास.
सर आप म्यूट ऑल कर देना. म्यूट ऑल.
म्यूट ऑल करो तो मुझे वो बार बार करना पड़ेगा ना. जब भी कोई बच्चा यानी एंटर होगा तो साथ में उसका माइक म्यूट अनम्यूट होता है. So please, this is a general guideline to all of you. When you join a meeting, keep your mic muted and keep your video off. ये दोनों चीजें कर लिया करें. सेटिंग में है एक दफा आप कर लेंगे तो आपका माइक म्यूट ही रहेगा. और दूसरा, when you attend the class, please respond to the teacher call. मैं बुला रहा होता हूँ, ना कोई जवाब आता है ना कुछ. Okay, let us continue further. So we are studying the different method of irrigation. First method of irrigation was the surface irrigation, and in that surface irrigation we have told you one is uncontrolled flooding, the second one is controlled flooding using strip method or border method. And this name is given to this method based upon the shape of the field. Usually width-wise it's narrow, length-wise it's too long, so it looks like a strip as it is shown over here in this. So one strip is this one, second strip is this one, third strip is this one, and they can supply water as per their ease using siphon, or they can provide by cutting the bank of the water jet. So his question was quite right that using siphon is illegal, but using siphon in distributary canal and minor is illegal. We are not showing you the minor or distributary canal over here. The water course is different from minor and distributary with respect to their ownership. Water course is operated and water course is maintained by the farmers themselves. They have the Varabandi practice over there. So they know that when it is my time to use the water. So of course, when they will be supplying water to this one and they are using siphon or cutting it, it is there. We are thinking, we are underlying that it is their time to use this water. So it will not be. So if I am getting water out of it, out of my time, so that will be theft. That will be punishable. So मैं किसी और के टाइम पे ये यूज नहीं कर सकता, but when it is time for this field, we can use it. So water from the supply ditch, ये बातें हो गई हैं मेरे ख्याल में. You can read it. This method is suitable for all types of the crops except those which require prolonged flooding. So when there is a prolonged flooding required, then instead of this method, next method that we make small fields, small kiaris. So that method is used so that the percolation should be same on all the places, because this method has a little bit slope. So this part will be getting higher depth of water if we soak it for longer duration, because it is higher elevation over here, lower elevation over here. We want that water should move. So that's why if we want to provide water for longer duration, so this method is not suitable. Then we divide this field into further smaller parts. So that method is then called as check method, or दूसरे method को क्या कहते हैं? Check method or basin method. अगर हमारे पास we want that we should have a level ground for which we are supplying water, so then we use this check method, and we use this method when a slope is excessively in the field. Excessive slope is there, तो फिर हम एक छोटे एरिया को लेवल करके उसको एक छोटी क्यारी या छोटा फील्ड बना देते हैं, and this method is called as a check method or basin method. Check is because of this stoppage or these ridges or these bund created over here. The check method of irrigation is based on rapid application of irrigation water to a level or nearly level, completely enclosed field. So the whole field is completely surrounded by the dikes or levees, and within that levee, the field is leveled, and we sometimes call them as compartments or kyari. Also in local language, we call them kyari. This is surrounded by levees. Water is admitted from the farmer water course to these plots turn by turn. So one checker box or one plot is fed, and then next is fed, next is fed, or a number of them can be fed simultaneously. This method is suitable for a wide range of soils ranging from permeable to heavy soils. So permeable soil से मुराद है sandy, silty, sandy soil. Heavy soil से मुराद है clay soil. Those are considered as heavy soil or less permeable soil. So they are suitable for all of these. While previous one, this method was considered to be suitable for those soils which have low to high infiltration rates. So low to high, moderately low to moderately high intakes rate or infiltration rates. So this method is further what we can say enhancement of the strip method. We need more labor in case of this check method or basin method because we have to make the small carries. This is more suitable. This is more suitable for orchards or for individual plants. This method is frequently used for orchard. For example, in this figure, if it is clear to you, I don't know, one check or one basin is made around one tree, seems to be a mango tree over here. So one check or one basin has been made around it. This is filled with the water, and then and within this within the ridges, this field is leveled. It don't have slope over here. So we fill it from the supply channel and then keep water over here for longer duration. Suggested size for these basins or strips, both of them we can use these sizes. So size depends upon the slope in that area, and size depends upon the type of the soil, and size depends upon the water supply stream size. So these three things control the size of the field. For example, if slope in the field is varies from 0.2 to 4%, then the width of the basin or width of the strip can be taken from this table. If slope is smaller, larger width is allowed. If slope is larger, then smaller width is allowed. So depending upon the slope in the field, so width of the strip can be utilized from here. For example, if there is a 1% slope, so 20 meter wide strip can be made. And if we have a supply channel of, let us say, 1 cubic water course is available, 1 cubic water course is available, which is nearly equal to 30 liters per second. So then, depending upon the soil type, we can have a total field area or carry area of 600 meters square if the soil is sandy loam. If the soil is heavy soil like clay, clay has less pre-percolation, so we can use larger area also for that one. We can supply water to a larger area if it is less permeable soil like clay, and if it is very high permeable soil like sand, we should use a smaller size fields or strips. 200 meters square is allowed in case of sand if 1 cubic supply channel is there. So these are the guidelines for making the field suitable for irrigation. If we use these guidelines, application efficiency will be better. Otherwise, either we will be not supplying sufficient quantity of the water to the whole field, or we will be wasting our labor. We will be putting more labor to make the smaller fields. For example, in case of clay, if I make smaller fields, it means I have to make more ridges, more levees I have to make. It means more labor work will I have to do. while I can provide even amount of water, good quantity of water to a larger field which need less amount of the labor work. So that is how we balance these things together, that the water should be applied in a better way while keeping the labor force also to a smaller amount. Another surface irrigation method, which is even better
So which to
with
decrease कर
respect
रहे
to
हैं
the
आप?
efficiency, is the furrow method. In furrow method, we make small channels having a continuous and almost uniform slope in the direction of irrigation. You can understand in a better way while seeing its figure. So this is the plot which is being irrigated while applying the furrow irrigation method. So difference between this furrow irrigation method and the strip method. In strip method, the whole only the ridges were far away from each other. One thing was that, and the second thing is the whole area between the ridges was soaked, was flooded. While in case of furrow, we have the small channels, so ridges are very close to each other, and nearly whatever is the width of the ridge, same is the width of the channel also. So the plant is cultivated, the seed is cultivated, or the plant is cultivated at the ridges, not at the bottom of this channel. And plant root gets water by through the capillary action from this channel. If you see this method, benefit of this method comes from the fact that while we irrigate the land, only part of the land is soaked, while part of the land is not 100% saturated. So part of nearly 50%, 70% of the area is not 100% saturated. Uh, while plant is getting water through the capillary, but the top of the soil is not soaked. So that reduces the evaporation losses. That give this method more efficiency, make this method more more efficient. But on the negative side, we have to make this ridges and high labor intensive method it is, as compared to uh, what we say strip irrigation method and the check basin method. This method is more labor intensive. Water infiltrates through the wetted ये मैंने बता दिया. Furrows are used to irrigate crops. So this is suitable for those crops which we call them as the row crops. There are some crops इनको हम कहते हैं row crop. For example, cotton can be said to be row crops. Cotton के जो plant है वो हम एक line में लगाते हैं. While wheat, usually we don't say that this is a row crop. We just spread the seeds in the field, and they grow all over the. Similarly, rice also we don't say that is a row crop. So there are some crops like vegetable, they can be said to be row crops. For example, tomato and other things like that. So in this way, we can use this method, and it is more efficient because the surface of the soil is not completely wet. 50% or close to that is unsaturated, and evaporation losses are less. Uh, Furrows necessitate the wetting of only about half to 1/5. So sometimes only 1/5 of the area is soaked. So means 20% of the area is soaked. So the rest 80% is unsoaked. So it reduces the evaporation losses. So how do it works? Water is distributed to the furrows from earthen ditches through small openings made in earthen banks. So ये है पानी supply कैसे करना है furrow को. At the one end we supply water either by the siphon or by cutting the ridge. Alternately, a small diameter pipe, ये वही siphon वाला तरीका बता रहे हैं. So furrow provide better on-farm water management capabilities for most of the surface irrigation. So out of the surface irrigation schemes, this is the most efficient method. We can see in the later part of the lecture that its efficiency reaches close to the sprinkler irrigation method, while its initial cost is not as high as the sprinkler irrigation. Keep in mind, in this method, we are providing water from the surface. We are using the gravity force given by the nature. We are not using the pump to supply water through the pipes. We are not using any pipes which are costly. We are using the earthen channels to supply water. So This method has some disadvantages which are mentioned over here. If we continuously use this method, it has been seen that the salinity enhancement is linked with the evaporation from the unsaturated land. In the furrow method, we say some part is unsaturated. So in that part, if there is what we call it evaporation occurs, some quantity of evaporation will occur. So salt will remain over there. While in comparison to that, in flood irrigation method, dissolved salt mixed in the water, they percolate down underneath. So salinity in the ridges increases in case of furrows as comparison to the other surface irrigation method. It has been seen that salinity in the ridges part enhances. So loss of water at the downstream end. So if the downstream end of the furrow is not closed, if we don't have a levee at the downstream end, we sometimes lose water at the downstream end. That can be rectified. Extra tillage, we have to plow in that area. So we have to put more labor force. So for making these furrows, special kind of the plows can be used. Cultivators can be used for making these channels using the mechanized way of agriculture. Possibility increase erosion is possible because not all soil is wet, so erosion is considered to be possible. Furrow irrigation requires more labor as compared to the other surface irrigation method. So these are some of the disadvantages, but with respect to application of the water, it is highly efficient as compared to other surface irrigation method. Some guidelines that how much should be the length of the furrow if the soil type is known to you. Clay, loam, and sand is differentiated. Sand, silt, clay, these are differentiated with respect to their size. In geotech, hopefully you have studied it. Uh, uh, Different people designate sand slightly differently. For example, one authority says that a sand is those particles which are more than 0.075 millimeter, larger than 0.075. Sometime in agriculture size, they say 0.05 millimeter is the cutoff. So small deviation is there, but sand is the larger size particles, then it is the silty particles, then it is the clay. Clay is usually said to be when the particle size is 0.002 millimeter and below smaller sizes than that. And loam is a soil type which is a mixture of clay, silt, and sand. So loam is considered good for agriculture. It has a good water absorbing capability and water releasing capability. So loam is a mixture of clay, silt, and sand. So if you have, for example, loamy soil, and if the slope available for the in the area is, let us say, is 0.2%, so we can practice furrow length of 220 to 370 meter, 220 to 370 meter, depending upon how much water we have to apply to the field. If we have to apply more water, we can go for a larger furrow. If we have to apply smaller quantity of water, we can go for a smaller water furrow length. So this will give you the guideline for defining the furrow length in the field. So before moving to the next subsurface irrigation, I would like to take a 5-minute break, and if you have any question what we have studied till now, you are welcome to ask. सरफेस इरिगेशन मेथड में किसी का कोई सवाल है तो यू आर वेलकम. In the subsurface irrigation method, there is a video. While I take a break, I use this video. In YouTube, you can see this, and then we can talk about it. I will not speak, but you can see the video. I think there was disruption in the net, so I start it again. Not start it again. I continue it again. What you have seen up till now, they want to tell us the subsurface irrigation using perforated pipes. They prepare the land, then they lay the pipes at suitable distance, usually 1 to 2.5 meter, they say. So they are laying pipes using this machine. Here is the coil of pipe and it is being laid. There is a plow which make a hole, and this pipe is laid in the field. So they are laying the pipes 1 to 2.4 meter width, space from each other. Then they supply the water and they check the distribution of the seepage around that pipe. So that pipe, when they lay that pipe, so the pipe has perforation, pipe has opening at about half a meter distance. Pipe has opening, emitters are there, and then they supply water to the pipe, and water goes to the soil and soak the surrounding area. So this black area is the area under the influence of the water supplied through that pipe. And they keep a usually low discharge through this. They say that half a liter, 0.6 to 1 liter per hour flow rate is sufficient in this case. And then they cultivate crop. Daily. The initial benefit for this is, they say, the area is accessible to the other activities of the agriculture, like if you have to apply some spray. So tractor can run through this area easily, and the spray can be applied over here. So these are the additional benefit of this subsurface, because ditches are not there, because level ground is there, and the crop is grown in rows. So there is area available for the tractor to move through this, and they can apply the what they call it, spray for pesticide and for herbicide. So then it grows and they can give them good. So that is a concept shown over here. This is the ground level. Pipes are laid underneath into the ground, and the pipes have the perforation. Pipe have the opening inside them. So this method is a combination of, we say, subsurface irrigation plus drip irrigation. Similar concept is there in drip irrigation. Pipe is laid in the field but at the surface, not under the surface. So in drip irrigation, we lay the similar kind of pipes at the surface, and then wherever is the plant, wherever is the tree, we provide a meter over there. Over here, we are providing a meter at half a meter distance from each other, and we want to soak the whole land. So with respect to drip irrigation, it is soaking the whole land, while in case of the drip irrigation, we only target the stem of the crop, we only target the roots of the crop, and the rest of the area is not soaked. Here, because it is crop is grown at the very close space, so they are soaking, they are making it at the regular intervals. So that is one of the video which can tell you subsurface irrigation method, which is the next method we are going to introduce to you, subsurface irrigation method. So
जब
there
हम
are two.
अंडर द सरफेस पाइपिंग कर देते हैं,
हाँ जी, हाँ जी।
तो सर हमें फिर फिक्स करना पड़ेगा कि हम एक ही किस्म की जो क्रॉप है उसको उगा सकते हैं, मतलब हम उसमें फर्रो तो फिर बाद में नहीं कर सकते।
When we have a underground pipe, so this pipe subsurface irrigation method is suitable for a special kind of soil which has porosity inside it. If it don't let water to distribute through the capillary action, we don't use it. एक बात तो ये। दूसरी बात ये कि आपने कहा कि हम फिर दूसरा मेथड, फरो मेथड कैन वी विल नॉट बी अप्लाइंग, ये कह रहे हो?
Yes, sir.
Yes, of course, if pipes are over there, you will not like to damage those pipes. तो आप सोच समझ के ये मेथड अप्लाई करोगे when you want to use this method for continuous basis. Or who will invest in a pipe system when he want to use it only for one season? Nobody will like to invest on it. तो जब आप ये यूज करोगे, you will not go for the furrow method. ठीक कह रहे हो आप? इसमें मसला क्या है?
सर यही पूछना था। ठीक है सर, कि मतलब हमें रिस्ट्रिक्ट होना पड़ेगा किसी एक क्रॉप
हाँ
के
जी,
लिए या
depending upon our soil, depending upon our investment capability. Obvious benefit from this method you can see, ये जो subsurface method का जो main benefit है, that is high application efficiency. एक तो you are supplying water close to the roots. You are not making water pond on the surface for excessive evaporation. आप pondage भी नहीं कर रहे. In all surface irrigation method, we are ponding the water at the surface. So that is maximum evaporation will occur from there. Over here, you are providing water underneath the ground level, so less evaporation will occur in this case. So ये बहुत efficient है, but initial cost is high and suitable soil is required for this purpose. So there are two variations of this subsurface irrigation. One you have seen using a pipe network. Another one is when you have an impermeable strata available at suitable depth underneath the ground. Ground की surface से 1 या 2 मीटर नीचे, if you have an impermeable strata and upper soil layer is porous, so that is the suitable condition for natural subsurface irrigation method. So subsurface irrigation method can be said to be of two kinds. The first one is in which we can apply water through subsurface irrigation if this condition is available. The first condition is impervious soil layer at suitable depth below the root zone depth. अगर हम कहें कि रूट जोन 1 मीटर या 1.5 मीटर है, तो उससे नीचे अगर impervious soil layer is available below that one, so we can use it. The reason for this impermeable layer requirement is that if we supply water to the subsurface, if impervious layer is not there, it will deep percolate. So second requirement is a very permeable surface soil layer should be there. So above the impermeable layer, the layer should be a good permeable layer which encourage the capillary action, which encourage the movement of the water through the pores in the soil. So sandy, loamy soil is required in the upper surface. Clay pan or impermeable soil is required at 1 meter, 2 meter depth underneath. We should have a uniform topography and with a moderate slopes. If this condition is available, then we don't need to lay pipes in the field. Then we provide water through a series of ditches. Ditch means channels. So through a series of channels, we supply water which are about 40 to 90 meters, 45 to 90 meters apart from each other. So we make the ditches at suitable spaces from each other, and we let the area soak by capillary action of the water. Water move through the pores into the soil, which is considered to be very permeable soil in the upper layer. So water soak in between the ditches itself. We don't flood that area. We don't provide water at the surface. We just provide the water in the side ditches, which are suitably spaced from each other, and the area in between is soaked through the permeability of the soil, through the capillary action of the water. So these ditches are usually 2 to 3 feet deep, 0.6 to 0.9 meter deep, and about 1 feet wide. And if suitable conditions are there, it supply water to the area. A variation of this is artificial sub irrigation, for which you have seen the video. In this case, a pipe distribution system is placed in the soil well below the surface, and this method is applying water is known as artificial subsurface irrigation. So soil that permit free lateral movement is necessary. So soil should be such that it allows the lateral movement of the water, and it has the capillary movement in the root zone soil and very slow downward movement. Vertical permeability should be small. Horizontal permeability of the soil should be large. The cost of such method is high, but it reduces the consumption of the water to a range of 1/3 of the surface irrigation method. So of course those methods which use pipe system, those are initially costly, but they are less water. Their water loss is less and their application efficiency becomes high. So that is one of the surface irrigation method, subsurface irrigation method. So out of the this high efficiency method of irrigation, one is the sprinkler irrigation method and one is the drip or drip का दूसरा नाम क्या था? भूल जाते हैं. Drip or trickle irrigation method. So these are the two of the high efficiency method. Sprinkler, if we see its video first, it will be easy for you to understand. There are a couple of YouTube links over here. One is this is 5-10 minutes video written over here, but one mentioned over here. This second one link is about an hour video. So that describes the sprinkler irrigation method in quite length and different components of this pivotal irrigation system. Especially they are talking about the pivotal irrigation, sprinkler irrigation method. So see them also. But what I want to show you, which one I would like to show you. So let us see what is this one. So I will skip it. Here sprinkler, one of the sprinkler irrigation method. Pivotal sprinkler. Central tower or pivot. So then we have the span which have the sprinklers attached to it. Here is the our sprinkler itself. Electric motors are attached to the wheels. It can go, the length can be as high as 300, 400 meters. Large can be used. And those are supported on these wheels. They are motored. See such kind of videos, and we can make ourselves more knowledgeable. So a couple of videos links are there. Please see them. So this sprinkler irrigation method, basically we provide water to the crop in the form of the spray of water, spray like rainfall. We provide water in the form of the spray of water in air, and then that droplets of the water fall on the crop and wet the soil and then provide water. Usually the rate of application of water in sprinkler irrigation system is, of course, it is controllable. We have the full control at the supply end, and we can even control the pressure at the end of the system also. Highly efficient method, highly technologically based method. Sensors are installed in it. We can control pressure, we can control discharge. So the rate of application of the water is kept, in case of the sprinkler irrigation method, less than the rate of soil infiltration rate. So if the infiltration rate is, let us say, 5 millimeter per hour, so sprinkler irrigation method will apply less than that, 4 millimeter per hour or 5 millimeter per hour, to avoid any water pondage at the surface of the soil. So that gives them efficiency. It will result in less evaporation losses. So in this method, because we can control the application rate easily, so we apply the rate of application is fixed in such a way that it should be less than the rate of infiltration of the soil. Infiltration of the soil, we have special instrument in which we can, using those instruments, we can measure the infiltration rate, and we can measure the infiltration rate. Those instruments are called as infiltrometer. So infiltrometer can be utilized to measure the infiltration rate of the soil. In this method, we apply water to the surface. It is not a subsurface irrigation method. We apply it to the surface. We avoid the pondage. We don't flood the area. In the surface irrigation, we flooded the area. So it has been brought into practice in the recent times in the 20th century. It was used in the humid regions, and it has high initial cost. It is more popular in developed countries and where water stress is high. Over there, this method is more popular. Sprinklers have been used on all types of soil on lands of uneven topography and slopes. So we don't necessarily need the very level topography as we needed in case of surface irrigation and subsurface irrigation method. We need to have the level topography in those methods. Sprinkler can supply water to relatively undulating area. So we save some money on the labor cost required for leveling the field. So we don't need much leveling of the ground without preparation of the field. We can apply sprinklers. And hopefully you have seen different variation of the sprinkler method of irrigation. For example, one you have seen the pivotal irrigation in the video. The simple sprinklers you might have seen in the lawns, in the what we call it, golf courses, in the orchard. Sprinkler guns are used. So in even UET, we have the sprinkler system installed in the Junaid Jamshed Stadium. A network of pipe is laid over there, and then sprinklers are installed, which are buried under the ground. And when they are pressurized, their emitters comes out of the soil, and they supply water to 10 to 20 meter around each sprinkler. So different variation of these sprinklers are there. They achieve high efficiency because they avoid the pondage. They have some problem that if there is high wind speed occurring over there, if there is high wind speed occurring over there, it can change the distribution of water uneven. Uneven application of the water is the result if there is high wind speed over there. So this is the following conditions are favorable for sprinkler irrigation. If you have very porous soil, high permeability soils, in that case, surface irrigation method are not suitable because we flood the area, so high infiltration rate cause high percolation. So in that case, this surface irrigation, this sprinkler irrigation method is suitable if soil is highly porous. So lands which have steep slope or erodible soil, we cannot apply surface irrigation method in those cases also. So then sprinkler irrigation method is better. So irrigation channel which are too small to distribute water efficiently, in that case also sprinkler will work better. Lands with shallow soils and undulating lands which prevent proper leveling requires. For example, if the good agricultural soil is very shallow, for example, if the loam is or the soil having high nutrients is of smaller depth, and you have to carry out its leveling process. So at some place you can lose all the soil. So without losing that soil, without leveling that ground, sprinkler method can help you irrigating that land. So if land is undulating and the soil depth is shallow, So if we don't want to avoid, we don't want to lose that soil from that area while the process of leveling we have to do. So then without leveling that land, we can apply sprinkler irrigation method. So it has some special features that we can apply because water is controlled from, by the irrigator, by the farmer. So we can apply small amount of water on more frequent basis. That will keep the area wet. That will keep the water available to the soil, to the plant in a better way. So we can apply small amount of water on a more frequent basis using this sprinkler method. Light and frequent irrigation are useful in case of during the germination of the new plants. So measurement of the quantity is easy, and using this piped method like drip irrigation and sprinkler irrigation method, you can easily apply the pesticide and the fertilizer while mixing it with the water. You don't have to carry out an additional work of application of the fertilizer and the pesticides. A separate work you don't have to apply. So you can mix those things in the supply tank, in the main pipe, and that can be applied evenly to the whole area. It reduces the percolation losses, it increases evaporation losses because we have to apply water in the air. Although we reduce the evaporation losses because we avoid pondage, but for some time water remain available in small droplet form in the air. We apply water in the form of the spray in the air. So that is an additional evaporation, cause of evaporation. So some water is lost through evaporation. So this loss can be avoided if we go to another method. We call it as a drip irrigation method. So we provide water to the root zone in drip irrigation or in trickle irrigation system. Frequency and intensity of the wind. So wind can cause sometimes a problem to this method. I told you uneven distribution of the water will be the result if there is very windy condition over there. So its efficiency is higher, something close to 75% is the application efficiency. A typical application efficiency for sprinkler is quoted. It is close to the furrow irrigation method. Why it is close to that? In furrow irrigation method, not 100% of the area is wet. While in sprinkler irrigation method, we are not putting water to the small part. The whole area is wet. So evaporation is relatively of the same level as that of furrow irrigation method. But it has other benefits like frequent application of the water, controlled application of the water, application of the nutrients and the fertilizer and the pesticides can be done easily in this method. Here is a simple system of sprinkler irrigation to tell you what are the components of a typical simple sprinkler irrigation method. Usually we have a supply of water or the source of water. So that is shown as a water tank or a well over here. We need something to pump that water. So pump and its energy source generator is there. So then we have, of course, some instruments to measure the discharge, to control the discharge. So valves and pressure gauges are installed. And sometimes if this water supply is from the raw source of water like river or like what we call it canals, so some kind of treatment need to be done before water can be supplied. If we expect to carry large size of the particles, then some treatment need to be done. If supply is from the tube wells, then I think no treatment is required. So then water is supplied to the main pipeline. We call it main line. Main line gives water to the branch line, or we call them as the lateral pipes, or lateral, simply lateral. We call them lateral. So these are relatively smaller diameter pipes as compared to the main line. So one main line can have a number of lateral pipes. Then lateral pipes are linked to the riser pipe, which are vertical standing pipes. Lateral pipes and the main pipes are on the ground to distribute the water to the whole area. Then stand pipes are the riser pipes are installed so that the sprinkler gun or the sprinkler nozzle which is attached at the top of the riser pipe, it can spread the water to the larger area. We can install these sprinkler head. We can install these pipes at the lateral pipes directly, but then area of the influence will be smaller. So then its area of influence will be smaller. So these are some of the components for irrigations, sprinkler irrigation method. So main things are source of the water, pump, and what we call it generator or electric power, then main line, then lateral pipes, then riser pipes, and then sprinkler gun or sprinkler head, and we need some flow measurement devices also. So this is that kind of sprinkler irrigation system. So this system is fixed at its place. One variation is possible that this lateral pipe, which is shown over here, it can be only one or two pipes which are movable from one place to the other place, or there are a number of lateral pipes fixed over there. For example, in this slide, if I tell you, कहाँ गया pointer? For example, this lateral pipes can be only one pipe, and if once this area is irrigated, we remove this lateral pipe from here and we can put it at the next place. We can put it at the next place. Another variation is that we can have number of lateral pipes and keep them fixed over there. So these are the two variation possible in this system. So this system is fixed for a certain area. Once we have plowed the area, then we place the lateral pipes. These main pipes are usually buried under the ground, while the lateral pipes are removable, and we remove them while we have to plow the area. We have to carry out the tillage, or we have to prepare the land for that place. So different kind of emitters or nozzles are possible, which can be seen in the literature. So this is another variation of the sprinkler irrigation method. We call them as the pivotal irrigation system. At the center we have the supply, and we have the what we call it sport in the center, and then this whole boom, which is 300 to 400 meter long, which is supported at suitable interval with the help of the wheels in between. So it rotates around a pivotal point. Sometimes we have a straight sprinkler irrigation system of this kind, and they move in a straight direction rather than a pivotal irrigation system. They move all along the field in one direction, and they carry out the irrigation practice. They carry out the watering of the field. So these wheels are provided with the power individually. They move at different speeds because if it is a pivotal irrigation method, then the outer part will have to move the larger distance, so over their speed need to be more. The inner part have to move it very small distance, so its speed should be less. So automatic control switches are there which control the speed of these motors and wheels. Water is supplied from one end, and then water comes to this U-shaped pipe, and then sprinklers are hanging to these drop pipes, and water is applied above the crop, and sometimes we can apply the water at the bottom of the crop also. If we increase the depth of this, so we can provide water to the lower level. So different crops can tolerate different kind of water. For example, we have some delicate crops like flowers crops. They don't we cannot wet the leaves and the flowers of those crops. Then sprinkler need to provide water, or the pipe need to provide water at the lower depth, and the leaves need not to be wet. but most of the crop can tolerate the water. So usually we supply water in the form of the spray from the top of the crop. Here we are showing you a sprinkler gun, metallic sprinkler gun, which rotate at its own when it is pressurized. Water comes out of the nozzle of this pipe. In front of the nozzle, there is a vane provided. There is a vane provided in front of the nozzle. When water jet comes out of the nozzle, it hit that vane, and this vane rotates because of the action of that jet. When it rotates, it has some spring assembly attached over here. It has spring attached to it. When it rotates because of the jet, spring tries to bring it back. So when it comes back, it hits the nozzle, and this nozzle is rotatable at this place. This is pivoted at this place. So nozzle moves a little bit in the horizontal plane. It moves. So this action, continuous action of the jet on the vane movement in one direction, and then it's returned back to the nozzle, and then nozzle moves to the next place. And this continuously happens, and you can see this kind of the spray guns working in the field, and seems to be a good practice over there. So if we compare this method of sprinkler irrigation with the surface irrigation method with respect to application efficiency, basin method, if it is efficiency, so this is a result of a research study carried out, I think, in Faisalabad by Mr. Rana and Arshad and Masood. They make the fields, they make the research field, and then they use the same crop in a number of fields, and they applied different method of irrigation, basin, furrow, and sprinkler. They have seen that for the same crop, I think they use crop of sunflower. They have carried out this exercise on the sunflower crop. They have seen that the basin irrigation method gave them an application efficiency of 70%, while furrow method gave them application efficiency of 80%, and this sprinkler method reached to an application efficiency of 90%. So that is how we can compare different method of irrigation. Other studies also can be quoted which compare the other method of irrigation or these method of irrigation for other crops. So similar results will be there. The flooding method will be less efficient. Furrows will be better than that, and then sprinkler and drip irrigation will be even better than that. So trickle irrigation method, hopefully you understand this. With the help of the network of the pipes, which have the pressurized water inside it, both methods, the sprinkler method and drip irrigation, both are the pressurized irrigation method. So in drip irrigation, usually we have lower pressure as compared to in sprinkler irrigation method, we have relatively higher pressure is maintained. So in trickle irrigation method or drip irrigation method, we provide a network of pipe. We provide a pipe in the field, and then we provide small openings in that pipe, and that opening is called as a emitter. If we see it first and then we talk about it. Similar system of water supply and water control as in case of the sprinkler irrigation system. Similar system is there. We have a main pipeline and we have the lateral pipes. A lateral pipe reaches to the field, and around each plant, depending upon how much water we want to apply, we can give a number of emitters. Sometimes we give only one emitter. So different kind of setting are shown to you. For example, over here they are showing you a loop sublateral with emitters attached to it. Over here they are showing you multi-outlet distributor. So one distributor has a number of emitters attached to it. Over here they are showing you simply a distributor with an emitter attached to it. So what is distributor? What is lateral? What are these main pipes? These are only, there is the difference of the size of the pipe. For example, these are the lateral pipes. So these are the distributor pipes. For example, these are the buried one. So these are the lateral pipes installed over here along with some emitters over here. So here is the whole components put together in a slide. So main pipe usually of larger diameter, half an inch to 1 inch. So over here they are showing you 13 millimeter supply pipe. That is about half an inch diameter. So then they have 4 millimeter micro tubing. So what they call it, they were calling it as a distributor. So this can work as a distributor. So this distributor will have the emitters attached to it. So emitters are shown over here with the help of emitters. So adjustable dripper. So they are calling here the dripper. So emitter or dripper are inserted in this distributors, and they have opening inside it, and water comes out of these emitters or dripper in the form of the droplets of water or a trickle of the water comes out of. So continuously it is pressurized, continuously drips are coming out of the dripper, and when these dripper are placed just close to the root of that plant, so it only soak only that area. So rest of the area you can see is not dry, rest of the area is not ponded. So huge saving of water that otherwise would have happened through evaporation and deep percolation, that is avoided. So its quantity is adjusted with the help of the pressure in the system. So if we want to enhance, then pressure need to enhance. One major problem with this drip irrigation is clogging of these small opening, choking of this small opening or clogging of this small opening. Even if the water is very clean, still some dissolved salts are there. So continuous application of the water at low pressure allow deposition of the salt within in the internal place of those emitters. So sometimes they become choke. So frequently the farmer have to go to each emitter and has to make it open with the help of the needle, or they have to replace these emitters. So that is one of the major problem. And the second negative or problem disadvantages is its initial cost is the second major disadvantage. So this is the introduction of this high efficiency irrigation method, which we call as trickle or drip irrigation system. This is suitable for individual plants or the fruits or the orchards, and people are using it for row crop also when water stress is quite high. Its advantages are high efficient with respect to water saving, good plant growth because right amount of water is made available to the plant to the root zone. That results in the good crop yield. It saves labor, because we don't have to make the carries, we don't have to make the strips, or we don't have to make the checkbox system over there or furrows over there. So less labor intensive. It controls the weed growth also, because not all area is made wet, so weed growth is not seen much in this case of irrigation system. And of course erosion will not occur, because we are not providing flooding of the area which have some velocity of the water. We are providing water in the droplet form, so erosion is not possible. So these are some of the advantages and some of the disadvantages written over here. Cost-wise, some studies have suggested, the latest study, if I said, which I have seen, is 2018, and that is given in a newspaper, that mention it cost around 100,000 per acre. Its installation cost. What you need a pump, you need the pipes, you need these small, which are not very costly, drippers and some stand pipes are these things. So initially it cost about 100,000 per acre. Maybe now it is a little bit higher because of the our cost of production has been enhanced. CPI is more. So if we see some study which have compared this method of drip irrigation with surface irrigation. So one study we see given by the Nazir Bey and others in 2005, they have seen that for the same crop, when they have practiced drip and the furrow irrigation method, the saving of the water was up to 32%. So they needed 550 up to 629 millimeter of water if they used furrow method for maize crop, while for the same maize crop, if they use a drip irrigation, only this much water was sufficient, 370 to 428. So 32% of the water was saved. So we can reach to the efficiency, application efficiency, more than 90%. Sometimes 100% of the water is utilized by the crop. The water which we supply to the field, 100% of that. So then application efficiency will be 100%. So I am leaving with you some of these videos which can enhance your visual seeing. Visual seeing is considered better. What they call it in China, they call it a picture is worth 1,000 words. So when you see something practicing in videos or you go to the field yourself, you can understand it in a better way. So this was a brief introduction of the irrigation method. Hopefully, it is a whole branch of agriculture, agronomy. So they study it in more detail. So we are just telling you name and their merits and demerits and major characteristics of each method of irrigation usually practiced over here. So any questions, you are welcome.
सर स्प्रिंकलर मेथड में कैनोपी लॉसेस को हमने कंसीडर नहीं किया, वो तो ऑब्वियसली होंगे।
ऑब्वियसली होंगे, कैनोपी लॉसेस को नहीं कहते हम, कैनोपी लॉस नहीं कहते, इंटरसेप्शन लॉसेस। सो वी हैव सेड दैट के इसमें हम लॉसेस जो अवॉइड करते हैं, दैट इज दोज लॉसेस व्हिच अकर बिकॉज ऑफ द पॉन्डेज। वी टोल्ड यू दैट while we apply the water from the air, so in that case more losses occurs because the droplets, small droplets in air, sometimes they evaporate. Very small, tiny, microscopic droplets, they will evaporate, they will not come to the ground. So that can be avoided if we keep the sprinkler as close to the field as possible, but then its area of influence will be smaller. So that is the give and take. Okay, so considering all these canopy losses, considering all these losses from the air, considering the benefit of not having the pondage, the net efficiency of the sprinkler irrigation method is better or comparable to the furrow irrigation method, not as high as drip irrigation method. ठीक हो गया?
यस।
और कोई किसी के सजेशन, कोई मशवरा? So I am taking attendance, downloading the attendance. And putting it on the WhatsApp. So किसी के सवाल है तो you are welcome. कोई बोल रहा था?
आज वाली स्लाइड्स भेज दें।
आज वाली स्लाइड मैं देख लेता हूँ। ये गया और सी में भी जाए। अब स्लाइडों की बात आ जाए। Let me close this slide and then कहाँ पे होगी स्लाइड? चलो जी, स्लाइडें भी भेज दी है मैंने और अटेंडेंस भी भेज दी। थैंक यू वेरी मच। स्टॉप रिकॉर्डिंग।